Have you ever heard a term BigQuery and wondered what is it, how it works, and what are its features due to which BigQuery is called a modern data warehouse? This video touches basics of BigQuery and its very common features. This video targets the absolute beginners and one who are preparing for any cloud certification exam. Okay, so let's dive into it. Let's today discuss BigQuery, the data warehouse powered by Google. So first of all, let me ask you, what is data warehouse? As we are targeting absolute beginners, let me quickly clear this concept. What is a data warehouse? So a data warehouse is a centralized repository designed to store and manage, analyze large amount of data, which could be structured and semi-structured, and it could be stored from the various data sources. Okay, so now we are clear what is data warehouse. Let's dive into what is BigQuery. So BigQuery is Google's data warehouse, which is serverless, which is highly scalable, and this data warehouse is having a built-in query engine. This query engine is very powerful and supports petabyte of query data. Secondly, what could be the sources of this data warehouse? For BigQuery, the source of the data could be anything. It could be a raw files, an asset, or Google analytical data, which is first of all stored in a Google Cloud storage that we will learn in later videos. It could also store the data from the streaming devices. Before directly storing streaming data into BigQuery, cloud data flow can also comes into picture to transform the data, and this data then after can be stored or loaded into BigQuery. So yes, BigQuery can have multiple data sources, and this could include Google's products itself, your application data, or the data that you have stored locally. Next, before diving into query, I want to show you the actual console of BigQuery. This is the main page of a Google Cloud. From here in the search bar, you can type BigQuery, or directly the option is available here to navigate to BigQuery. Let's click into it and you will be landed on the BigQuery console. You will see several default options enabled here. First of all, let's navigate through all the options available in the BigQuery console. On the first left side panel, there are many APIs that BigQuery is providing. As of this video, we will be exploring BigQuery Studio only. In this explore panel, you will be having all your projects and your data. So yes, as we are in this current project, you will see the project here, and all the data set which are stored under this project will be visible under this. Now you can add the external data sources. For example, I have added BigQuery public data. So you can go to this add button and can add this project by clicking on star project by name, and you will have to exactly type BigQuery-public-data, and you can use BigQuery's public data sets which are available for everyone to query. You can play around with this data to get familiar with BigQuery and all the query options that are available within BigQuery. Okay, we got the 10,000 feet overview of this BigQuery console. In the upcoming few minutes, we will be exploring how we can query the data and what are the options to save these queries. Okay, now we are at the section of querying the data. BigQuery is also providing a query console. In this query console, you will be able to write your SQL query, and these SQL queries can also be saved. There are various options available to save these queries. Firstly, you can save this query by query itself. We will see that option later in few seconds. Secondly, you can save this query by a view. There are two types of view. Firstly, the first one is a standard view. So what is this standard view? So actually, this standard view is a virtual table defined by SQL query. When you query a standard view, BigQuery executes the SQL query that defines the view and returns the result. Now, how can you create a standard view out of writing SQL query? So before you select or any kind of query, you will have to write this keyword create view, and you will have to name this view. This will save your query as a standard view. You don't have to write a standard view, there is no option like that. But to create a standard view, just use this view keyword to save your query. Okay, before playing around with the query, let's first of all explore its usage and its characteristics so that we can get more curiosity to learn this standard view. For the characteristics, the first one is as it is a virtual table, it is not occupying any physical storage. Yes, this will be a virtual table and you are not paying for any physical storage. Another thing is it is gonna be up to date. If you are writing a query on 10,000 rows and in the next day another 10,000 rows has been appended to that table, this query or your standard view will be updated with this 20,000 rows result. So this standard views are always up to date and you are not paying for any physical cost. Now what could be the usage? So use when the underlying data changes frequently, just for the example that I gave, and you want to get the up-to-date result every now and then you can just grab the rows or the columns that you want and create a view out of it, and you can create a visualization on top of it by selecting this view in any BI tool such as Looker Studio. Standard view is also suitable for complex queries that need to be resolved without worrying about a storage cost. Okay, so we got the high level overview of what is standard view and how can we use that. Now let's take a look at how can we store a query as a standard view. Okay, in our BigQuery console, actually I have created a standard view out of it to save your time. Here, first of all, you will see your project like this, and in this three dots you will have an option to create a data set. Here you can name your data set, for example, my first data set, and you will have to select the region. You can select the region. By default it will be a multi-region. You can select a region, and from this drop down you can select any region that you want and which is convenient for you. Remember, if your source is in US East 4, you will have to create your data set in US East 4 only, because your source and destination, the destination is this data set, BigQuery data set. So the source and destination region should match. Now after this, there is no need to provide any advanced option. By the way, you can always navigate to that and customize your encryption and anything as such. And then by clicking this create dataset button, you will be able to create your dataset. Now I already have my dataset created under this project, which is named as dataset for YouTube, and here I have loaded one table. How can you create a table? Again, just click on this 3 button and navigate to create table. You will be prompted to more information. If your source is your CSV file which is locally stored in your computer, you can select upload, and for selecting you can browse your file by this. Alright, I already have my data loaded here. There is housing data that I downloaded from the Kaggle for the simplicity, and here is our data. Now this view also provides several options, as you see. So first one is the schema. So it will give you all the column names and its type as a schema. It can be also defined or auto detected. Now the other tab has the details. These details are regarding the data set, where is it stored, and how many rows and what is the physical storage it is consuming. This preview option is very important. If you want to take a quick look at your table, what is there inside this table, you can always use this preview button. This preview button is free of cost. Yes, if you run a select query on these rows only, you are paying for that query, but this preview button gives the same overview of your data, but this is no cost option. Now these 3 are very important features that BigQuery is providing to take a quick look at your data. Now let's navigate to the query that I was talking about, that is the standard query. You can click on these 3 dots and open a query like that. Okay, I already have the query written in there. Let's navigate to that query. All right. Okay, so here I wanted to create a test data set over area and price columns only. So what I did is that I selected area and price columns from this table, the housing data, and I created a view top of it. So you will need to add this line additionally to create your view. After running this query, it will save my query as a view. As you can see here, this is a view which is created by this query. You can also query this view, and you can also use this view in your BI tool. Okay, we got understanding of how we can create a standard view and how we can leverage this view in other BI tools. Okay, so we got the 10,000 feet overview of what is standard view, and we also got the overview of how we can create that in the BigQuery console. Next, another view that is provided by Google BigQuery is materialized view. It is a pre-compute view, just like standard view, that stores the results of a query. When you query a materialized view, BigQuery retrieves the pre-computed results, which can significantly improve your performance for certain types of queries. How you can create a materialized view? So materialized view is also a type of view where you are also storing the query, but at this time you are actually additionally requesting a storage in BigQuery. So yes, this is gonna be your physical storage, and this will cost for the physical storage too. What is the keyword to create this materialized view? So for the standard view, we just was using view only, and for the materialized view, we're gonna use create materialized view, and we're gonna give the ID to that view to store under your dataset. Yes. What are the characteristics of it? As I said, it is consuming a physical storage, it is a faster query performance, and since the data is pre-computed in the materialized view, it is faster than the standard view. And it is incremental update, means it is automatically makes the updates when the underlying table is changed, although not in real time, but it has the incremental update in it. What could be the use cases of this? So used when the performance is very critical and the underlying data doesn't change very often. So when the data is not real time, you can create a materialized view after applying several computation on it to retain the performance that you want to get. The ideal use cases for this also would be the dashboarding, reporting, and frequent querying larger data sets. Also, if you are having a very complex query that you want to run now and then you can also save this as a materialized view and can leverage those computations in seconds. Let's take a look at the materialized view. Okay, so if you want to create a training data set as a materialized view, you're gonna give materialized view option here. I made a spelling mistake. Materialized view, and when you are giving materialized view, you cannot give the limit. So it will save your view as a materialized view, and let view. And by running this query, this will save your view as a materialized view in your table. And also you can interpret that this is consuming a physical storage. Okay, this is how you can select the data and create a materialized view out of it. Okay, another exciting part for the BigQuery is creating ML model. Imagine you can create ML model just within your BigQuery console. Isn't that amazing? Yeah, we'll also try creating our ML model in there, and we'll do some prediction on it. What are the key features provided by ML model in BigQuery? So the first one is these are SQL based. You don't need Python or R knowledge to create a model in your BigQuery. So just use SQL and your model will be ready on that. Integration. So it seamlessly integrate with existing BigQuery workflow and dataset. And there is no need for the complex coding, as you can use SQL based syntax in creating ML models in BigQuery. Scalability, of course it is BigQuery, so it leverages BigQuery's scalable infrastructure for training and serving ML models. These are the key features. And what are the models that it supports? It supports plenty of models such as linear regression, logistic regression, k-means, clustering, and all the other models that you can imagine. Now When should you create ML model within BigQuery? For example, if you are creating a looker dashboard and in that you want to show current sale and in future sale by predicting the sales in the future for 6 or 12 months, you can within BigQuery you can create a ML model for the sales prediction and can leverage those prediction data in the Looker Studio, and it's gonna save a lot of time and it will be very easy. Although creating and leveraging Python's model, machine learning model, will be the best choice for lot many other reasons, but for the faster usage, just like for the reporting purpose, you can create a model within BigQuery and you can leverage those model, and also no Python expertise are needed. Now let's navigate to ML models in BigQuery. Okay, here my data set is a housing data set and I'm gonna build a very basic model on it. Now this video is not targeting to create a ML model. We are just gonna test how we can create ML model in BigQuery by just using SQL syntax. So that's why what I'm gonna do is that there is some correlation between this price and area column. So as we can also kind of guess, when the area increases, price should also increase for the house for a very basic scenario. Of course, there are a lot many other features that could contribute in that, but let's not talk about that. Okay, for the training model, what you can do is that here we're gonna select the same thing that we want to kind of train the model on it. So that's why I selected area and price on which I want to train my model on. So the very basic select query first of all. So select area and price from this data set. But what I want to do on top of it, so I want to create a model and I named that model with predict price within this data set, and I give this model's option as a linear regression. As you can see, the data is varying and linear regression model is the most suitable one, so that's why I'm selecting that here. And what will be our output feature? So that will be a price, so that's why I'm specifying price here. Okay, this is how you can train your model, and after running this query you will be able to save your model just like this in here, predict price. Okay, at the end it's gonna create a model underneath these models. Yes, it got successful, and it took a very minimal time because this table has only around 500 rows. Now our model is ready. How can we evaluate that model? There is also a SQL syntax to evaluate this model, very basic. Yes, so as usual, first of all write select statement for your area and price, and we're gonna use ml.evaluate method, which is built-in function in BigQuery, and provide the model that you have created. So this is the model. How can we get the ID of it? You can click on these three dots and get the ID from here and copy paste that here. We're gonna select everything, and by running this you will be able to get several evaluating methods as a result. As I said previously, our goal is not to create an ML model and not to kind of evaluate the ML model. We are not gonna focus on it. The results are very bad, but yeah, we haven't put any efforts for the feature engineering. That's why this is happening. Okay, now the model is also evaluated, and let's create some prediction on it. I did not have splitted this data in training and testing data, so I'm just simply creating prediction on the actual table only. Here we are gonna use ml.predict method and gonna select everything from the table, housing table that we got, and what columns that I want the prediction on. So I want the area and predicted price to be there in the prediction table. So let's run this query, and here as we see the area is here and you can see the predicted price. Now this is a very simple way to kind of create your model and run the prediction on it. Okay, now we got a very basic overview of how we can create a model in BigQuery, and there are built-in functions through which we can evaluate model and generate a prediction on it. This prediction can be used very simple use case is the BI report. Alright, now in this video we got a very good understanding of what could be the data sources, what could be the storages, and how we can query the data and what are the options available to store those queries. And lastly, we discussed how we can create ML model within BigQuery. Another thing that I want to quickly share is how we can connect this BigQuery if these clicks are disabled. So yes, in most enterprises you won't be able to kind of click on this create dataset option and would be able to create the dataset. That is mostly disabled for the security purposes, or the data insertion method that company is using is not supporting this kind of option. So that's why this could be disabled. So what could be the other option to create your dataset and table within BigQuery? For that, you can use Python client library. Alright, here this is my workstation, and for example I want to load my data, or I want to create my data set within BigQuery. I can also do that by using Python client library, and just forget that dialog box in there because I have started this workstation 30 minutes ago. So you can write the BigQuery Python client code in there in any code interface, and you will be able to create the data set. I will create a separate video on it, how we can create a data set by using this kind of IDEs in Google Cloud Storage. Yeah, I will be having one video on how we can use this Python client library and also authenticate BigQuery to allow external API to create table and store data in there. But as of now, in this video, let's conclude it with what we learned, and thank you so much for watching.